all of you?
Yes,
Yes,
sir.
sir.
Okay. So
Yes, sir.
we discussed that F is equal to C minus P plus 2, where C is called component, F is called phase, and F is called, sorry, P is called phase, and F is called degree of freedom. So we'll discuss component C is equal to N minus C, where N is equal to number of constituents, E is equal to number of independent chemical equation, and where you find that when there is a INC there, you consider electrical neutrality as one solution. So today we'll discuss what is degree of freedom. So degree of freedom is it visible to all of you?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
Yes, sir.
It is visible though?
Yes, sir.
Hello. Okay.
Yes, sir.
Yes,
I
sir.
guess.
So,
Yes, sir.
Yes,
so
sir.
degree of freedom, we can say degree of freedom is particularly F is equal to C minus P plus 2. Once you know the component of a system and phase, then you can calculate degree of freedom. So degree of freedom is defined as the minimum number of independent variable factor such as temperature, pressure, and concentration, which must be fixed to define the system completely. That means the intensive property like temperature, pressure. So we can say that the minimum number of independent variable factor such as temperature, pressure, and concentration, which must be fixed to define the system completely. That is called the degree of freedom. And we can say that the degree of freedom of a system, it is maybe 1, 2, 3, or 0. So what do you mean 1 degree of freedom, what do you mean 2 degree of freedom, what do you mean 3 degree of freedom, what do you mean 0 degree of freedom? So if a system having degree of freedom 0, you can call that system is non-variant. And if a system having degree of freedom 1, you can, it is a univariant. If it is 2, it is called bivariant. If it is 3, it is called trivariant. So what we discuss here, let's say example, for example, ice, water, and vapor. Now tell me that how many number of phases here in this case? Soumya Ranjan Panda, Soumya Ranjan Kailu, how many number of
Three, sir.
phases? 3 phases. Now it is a Trupti Naik. You tell me that how many number of component here?
Sir, 1.
1. So here if C is equal to 1, that is water is the only chemical formula to define the all the phases, and here P is equal to 3, then Nishan Behra qualitative degree of freedom keta hoba?
So, degree of freedom is 1.
तो कोई चले 1 ହେଲା बे हां जदी मोर P ହେଲା 3 और C ହେଲା 1, so F केता होबा? C minus P plus 2 केता होबा? 1 minus 3 plus 2 केता होबा? हां
Sir, 0.
1 के
0.
Yes, sir. Again.
So the degree of freedom of this system is 0. That means the point is called invariant. What do you mean invariant? Hello.
So there is no variance in all the three I mean, sir, in ice, water, and vapor.
So it is called invariant. So we can say that the point at which 3 phases coexist, and for one component system, the degree of freedom is 0, and that point is called triple point. So triple point is a point where 3 phases coexist, and invariant माने एठी हमें किछि vary करिवनी. For example, here in water system, it is a fixed value of temperature and pressure. If the pressure is 4.58 m mercury and temperature will be 0.007 centigrade, then you have a system. You have point, that point is called triple point. So जो जगह रे जो हमें पढ़िया phase diagram, the phase diagram where the three phases coexist and degree of freedom of that point is 0, that point is called triple point. So here you have ice, water, vapor, all are in equilibrium. So since all are in equilibrium, here P is equal to 3, C is equal to 1, so F is equal to 0. So एठी मु किछि vary करिबि नै. जदि vary मोर कली ताले मोर कोन हबो ना, either you get temperature, either you not get equilibrium between solid, liquid and vapor. जदि मु बर्तन एठी खाली ice और water नेबी ताले मते को एठी ice water नेले एठी मोर P केते हबो? खाली ice water equilibrium P केते हबो? 2. ताले C component केते हबो? What is component here? 1. ताले मते को degree of freedom केते हबो? degree of freedom केते हबो?
1.
ताले system कोन हला मोर is univariant. So you put in ice and water here, or water vapor, or ice vapor, anything you take. So here P is equal to 2, C is equal to 1. So that gives us to degree of freedom 1. So system is univariant. That means either you can vary temperature. If you know the value of temperature, you can know the value of pressure. So either you can vary 1. Then after that, if you take only ice is there, what will happen? If only ice, what will happen? What is the phase here?
1.
Phase कितना बड़ी?
1.
Phase 1. Component
1.
What is degree of freedom?
1.
2.
Degree of 2 होगा. So that means the system is bivariant. हमें तले phase diagram को जिबा पढ़िया पई हम देखिबा जो जगह रे मोर गोटे फेज थिबो सेटा हमें ऑटोमेटिकली 1 कोन सिस्टम ताको बाइवेरिएंट कहबा. दीटा फेज थिले ताको हमें यूनिवेरिएंट कहबा. The तीनटा का phase exist करछि इक्विलिब्रियम, that is कहबा non variant. So degree of freedom we can calculate by using this phase rule concept. Like so we can say that here that degree of freedom 0 means the three phases will be in equilibrium only at a particular temperature, pressure. So system does not have any degree of freedom, so it is non variant or zero variant. Where mu jo कहली तीनटा phase थिले, then mu जरी वही जो जोटा कहली water and water vapor, here liquid water is in equilibrium with water vapor. So hence any one of the degree of freedom such as temperature or pressure has to be fixed to define a system, therefore degree of freedom 1. So if you want to define a system, you have to fix either temperature or pressure, because the degree of freedom is 1. Here P is equal to 2, component is 1, so degree of freedom 1. That means any one of the variable like temperature, pressure, you have to fix to define that system completely. Similarly, if you go for the case only gases, here let's say example gaseous mixture of N2H2. Here P is equal to 1, so component 2, so its system is bivariant. So you have to define both temperature and pressure. So like this, you can define the system completely by whether degree of freedom 0 or degree of freedom 1 or degree of freedom 2. So why I am discussing this thing 0, 1, 2? Because when you study the phase diagram of a system like water and sulfur or any one component system, so we have to define the degree of freedom of that area or phase or line. जहाँ भी मुझे कोई भी degree of freedom टा तारा phase काढ़ीबा. So हमें तले phase diagram पढ़े ये जो जिनसे ना पढ़ले component, phase और degree of freedom तारा application होची when you go to the phase diagram of a substance. So in that phase diagram, what will be discussed in phase diagram? Now it is visible to all of you?
No, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So our basic focus is we know what is the value of F, what is the F degree of freedom, component, phase, but our सबूरो main name we have to discuss the diagram, phase diagram. So, what is a phase diagram? Now, I'm going to borrow this to छोटो बहुत बड़ा एरिया को small माने ये देखेगा what is diagram because to represent the largest in a small. So, phase diagram is a graphical way to summarize the condition under which different state of substance are stable. So we have to summarize that condition and which different state of substance is stable. And in a phase diagram, what we have done that the diagram is divided into 3. Remember, in a phase diagram, we will find there is a 3 area and the core in each area when the boundary of the phase change. What is the boundary like? phase diagram कौन पाइले area पाइले और area का हमर phase बीटा phase को boundary दिबो bottom line boundary means कोई भी हम India Pakistan का boundary of the line is called LOC, line of control. You go to India, China, then that boundary is called LAC, line of actual control. So you can have a boundary between solid and liquid state one line. Then you go for liquid and vapor one line, then solid vapor another line. So our line है देखो हमें को कहबा जोड़े दीटा स्पेस को सेपरेट करते हो बाउंड्री टा थिबो से लाइन ऊपर दीटा लिक्विड तो लाइन तले उडिन से लाइन ऊपर उडिन से थिबो से तीन मिडल मिसिथिबे ताको हमें ट्रिपल पॉइंट तीन डाक मिसिथिबे सो हमें ए टाइम रे पाइबा एमिजिंग जो जोड़ी हमरो यू हैव फाइंड ए one page that is called area, 2 page that is called line, 3 that is called you can call this is 3 point. So let's move to a common diagram. This is a common diagram. Look at this. I mean, now look at this is a sample diagram, sample phase diagram. What is that? Now this diagram consists of 3 curves. More an example so in diagram में 3टा कर्व को देखा हम डिवाइड करछे रीजन ଗୋଟେ solid, ଗୋଟେ liquid, ଗୋଟେ gas. So we can say that we have a area, let's say DAC where gases exist, then area ABC where liquid exists, then area ABD where solid exists. So we have got area, one area is gas, other is called liquid, other is solid. So ADB solid, then DAC gas. So look at line where AC separate liquid and gas, then AB separate solid and liquid, then AD separate solid and gas. So our basic purpose is we have to explain line कौन the name कौन अच्छी what is name of the line, what is condition, what is degree of freedom, say line रे could start could end है line is chemical कौन area कौन then move line of control boundary time को जे LOC line of control but India time को LSC line of actual control. So same thing जो हमें AC कर्व हमें AC कर्व रे हमें ताको कौन करबा ना करबा हमें जो नेमिंग करबा कर्व एनी डायग्राम रे से टेस्ट टा खूब चेंज the process na ja rahiba the curve na ta share rahiba the AC curve re mo the liquid to gas jaychi. So liquid to gas is known as what is the liquid to gas coming liquid to gas
vaporization.
so we can call so it is called vapor pressure curve. AC कर्व नाम दबा वेपर प्रेशर कर्व. So you can call this curve curve AC name is vapor pressure curve, right? So class machine. Sorry. So now we can call this curve AC is called vapor pressure curve. So sorry, liquid to liquid gas is called evaporation. So you can call this name of the curve is vapor pressure curve. Now look at the curve AP. Now AP separate solid to liquid. If solid to liquid you separate, then you call solid liquid known as melting or fusion. So you can call this fusion curve. So it is water maybe you can call AB is called fusion curve of water. Then sulfur maybe fusion curve of sulfur. So the curve more example कोची सेमती मु AC curve ना कोई भी fusion vaporization curve of water और vaporization curve of sulfur. तो मैं जहाँ भी सेमती curve ना देवी. सेम AD curve कौन करची ना जो curve separate करची solid or gas. So solid gas is called solid to gas. It is called solid to gas process ना कौन थी?
Sublimation.
Sublimation curve. So बर्तमान हमें देखिले ये जो फेज डायग्राम रे हमें एरिया देखिले तीनटा एरिया गोटे एरिया ABC, then area DAC, then area ABD. Then you go to line हमें देखिले line और curve AC का नाम ले vaporization curve, AB fusion curve, DA sublimation curve. Then हमें बर्तमान कर्व को सिग्निफिकेंस हमें सब जगह हमें काढ़िबा बर्तमान डिग्री ऑफ फ्रीडम काढ़िबा. Look at this. In AC curve A ऊपर होची liquid, it is gas. So along that line or curve liquid and gas are in equilibrium. माने इकन मुझे वाटर ने भी तो H2 liquid एक vapor लिखी. तर मतलब को ये curve रे liquid gas equilibrium हैला एडी फेज केता होबा and it is a one component system. It is one component phase diagram is plotted by taking temperature along x-axis, pressure along y-axis. So this is an example of sample of one component phase diagram taking temperature along x-axis, pressure along y-axis, and here in the curve AC, liquid and gas are in equilibrium. So your phase P is equal to 2, C is equal to 1 because it's one component system. What is degree में कितना हुआ? एक लाइन में डिग्री में कितना हुआ? मुझे पता है कब ऑन इन राउंड अच्छी रे what is the degree of the line AC? देखो मुझे जहाँ को डाक्टर जैसे रेस्पॉन्ड कर दो आई एम ट्रीटेड दिस एब्सेंट तो मैं लाइन में था देखो तो मैं ऑन करके पढ़ो तो जानी थी so on in राउंड आर यू दैट?
Yes, sir.
अरे मतलब AC कॉल डिग्री में कितना हो? AC कॉल में मेरी P कितना ला? अरे P कितने? अरे 80 मोर 3 टा फेज अछि लिक्विड गैस कंपोनेंट ला 1 सो डिग्री में कितना बैठी रो? कितने डिग्री में? क्लास सुनो ना कौन कुछ हेलो अनिमेश दास अनिमेश कहलु के डिग्री में दबो अनिमेश दास अनिमेश दास श्री हेलो भाग्यश्री don't give message tell that explain that Nagesh, are you there?
जैसे पीसी यूज कर सकते हैं माउस में तो
No.
So
Sir,
One.
Maximum number of degree of freedom possible is equal to C plus 1 for a system having component C. देखो एटी मु एरिया रे पाइली गोटे फेज लाइन रे पाइली दीटा फेज आउ पॉइंट रे पाइली तीनटा फेज सो मु गोटे फेज पाउची दीटा फेज पाउची तीनटा फेज पाउची सो आई कैन से दैट द मैक्सिमम नंबर ऑफ फेजेस that can possible for a system having component C is equal to C plus 2. जदि मु 1 component नेबी तर मोर maximum 1 plus 2 is equal to 3. So maximum तीनटा फेज एग्जिस्ट कर परिबो तीनटा फेज कोन कोन तीनटा फेज एट ए पॉइंट एग्जिस्ट करिवो देखो एटी मोर एरिया रे गोटे फेज एग्जिस्ट करची लाइन रे दीटा फेज एग्जिस्ट करची और पॉइंट तीनटा फेज एग्जिस्ट करची सो जोटी हमर तीनटा फेज एग्जिस्ट को दैट इज कॉल्ड ट्रिपल पॉइंट जोटी गोटे फेज यूज करिवो ताको हमें कहबा एरिया जो दीटा फेज ताको हमें कहबा लाइन सो दिस इज एप्लीकेबल फॉर वन कंपोनेंट सिस्टम सो हमें कहि परिबा इफ द कंपोनेंट इज C the maximum number of degree of possible is equal to C plus 1 the maximum number of phases is equal to C plus 2 so हमें देखिले एटी जे गोटे वन कंपोनेंट सिस्टम रे मैक्सिमम डिग्री ऑफ फ्रीडम 0 0 1 2 ताटो अधिक होनी मैक्सिमम फेजेस गोटे पॉइंट रही पछ गोटे जगह रे आइदर 1 रहउची जो एरिया कहउचे ताको हमें 2 रहउची ताको हमें कहउचे लाइन और कर्व और 3 रहउची जोटा को ट्रिपल पॉइंट कहउचे एरिया रे डिग्री ऑफ फ्रीडम 2 एरिया बाइवेरिएंट you require temperature pressure to define that point in that area line is univariant either require temperature or pressure and point is invariant non-variant that is your fixed value of temperature you cannot vary anything so and remember one thing whenever you plot a diagram between diagram for one component system the temperature taken in x axis and pressure is y axis so this is called TP diagram of one component system so हमें तो देखो सही जिंस सेम सो एटी हमें जोड़ा देखिले हमें ए बी सॉलिड लिक्विड हम कहली इट इज सॉलिड लिक्विड इक्विलिब्रियम देन सॉलिड लिक्विड देन हमें पाइबा एटी लिक्विड और गैस इक्विलिब्रियम होचे लाइन रे एसी रे तापरे हमें जिबा इक्विलिब्रियम पाइबा एटी ए लाइन रे डी ए रे सॉलिड गैस ए लाइन रे एटी सॉलिड गैस देन आउट जिंस होची हमें जिबा गोटे पॉइंट a point देखिबा ए पॉइंट जो कहली में पॉइंट ला दिस पॉइंट A is called triple point where the B C and D all at three meet each other so this is called triple point and this point is degree of 0 just कहली जोटा तापर हमें देखिबा आउट इज देखिबा हमर एटा पॉइंट C so it is ए जो जगह रे हमें it is critical temperature means the temperature above which liquid state of substance no longer exists regardless of the pressure गोटे सब्सटेंस रो लिक्विड स्टेट एग्जिस्ट करिवो नाही जो टेंपरेचर हम कहबा दैट टेंपरेचर क्रिटिकल टेंपरेचर सो ए जो पॉइंट सी देखिली से पॉइंट सी रो ऊपर को लिक्विड पे एग्जिस्ट करिवो नाही एंड क्रिटिकल टेंपरेचर एंड क्रिटिकल प्रेशर मेक्स ए पॉइंट इन फेज डायग्राम व्हिच इज कॉल्ड क्रिटिकल पॉइंट सो लुक एट दिस इज क्रिटिकल प्रेशर this is critical temperature you plot this is temperature pressure so the point C is called critical point so critical point ro upur ku mo liquid pe exist karibo nai and critical temperature la the upur ku liquid pe exist kariboni regardless of pressure बर्तमान मु कहबी critical point और triple point just like खंडगिरी और रसुलगढ़ स्क्वायर ऑफ भुवनेश्वर माने कहला खंडगिरी और रसुलगढ़ कोन 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 अछि खंडगिरी और रसुलगढ़ कोन अछि भुवनेश्वर प्ले के अछि रे अरे खंडगिरी और रसुलगढ़ कोन अछि की कहि पर एनी पर भुवनेश्वर के ना हेलो
सर खंडगिरी हाथी गुंफा अछि
खंडगिरी रसुलगढ़ भितर कोन हाथी गुंफा ता भितर रसुलगढ़ और खंडगिरी ट्रैफिक खंड रसुलगढ़ कोन अछि ता भितर हाथी गुंफा गड पड़े आगे कहि परियो मोर कॉलेज भूली जाई छन आसी खंडगिरी छक रसुलगढ़ छक कोन अछि सिद्धार्थ दास आर देयर तो घर कोठी आ तू कह खंडगिरी घर तो कह खंडगिरी और रसुलगढ़ कोन अछि तमरा खंडगिरी रसुलगढ़ भितर भुवनेश्वर स्मार्ट सिटी अछि if you want from the north south side chennai rasla bale खंडगिरी हो मेन पॉइंट एंट्री पई आ सेपटे कालकाट साइड ले रसुलगढ़ हो एंट्री पॉइंट सो खंडगिरी और रसुलगढ़ छक भितर तमर गोटे भुवनेश्वर स्मार्ट सिटी अछि तू कहबी मो एयरपोर्ट ओलेक आसली कि ट्रेन आसले नहीं तो दिस इज टू इंपोर्टेंट एंट्री पॉइंट ऑफ द भुवनेश्वर वन इज खंडगिरी छक from that Chennai side and one is Rasulgarh Chaka from the Calcutta side where national highway pass through this smart city. Similarly, in between triple point and critical point, look at this. This is a triple point, this is critical point. Sorry, this is critical point, this is triple point. So in that point, triple point, critical point, liquid phase of a substance exists. So we can call triple point and critical point. It acts as a frontier post for existence of a liquid state of a substance. क्रिटिकल पॉइंट रो ऊपर को मो लिक्विड फेज नाही ट्रिपल पॉइंट रो तळ को मो लिक्विड फेज नाही सो लिक्विड फेज ता कोड रोजी को डायग्राम रो ना क्रिटिकल पॉइंट और ट्रिपल पॉइंट so we can call critical point and triple point as a frontier post for existence of a liquid phase or substance so हमें जो phase diagram में critical point को जता ऊपर liquid phase नथिबो ट्रिपल पॉइंट तळ लिक्विड भी नथिबो बट क्रिटिकल पॉइंट रो डिग्री ऑफ फ्रीडम 0 नाही यदि टू फेज एग्जिस्ट करथिबो बट ट्रिपल पॉइंट डिग्री ऑफ फ्रीडम 0 थिबो so in between that critical point triple point you have a liquid phase substance right so this is a common idea about a phase diagram माने हमें प्रथम डायग्राम लिख कर नीट एंड क्लीन ड्रा करिबा नॉट there is some issue regarding power cut hello
Yes, sir.
okay एबे तो it is not visible
Yes, sir.
okay so we can
Yes, sir.
call this is a triple point and critical point so हमें गोटे फेज डायग्राम कला बळे हम बुझिबा जे लेखिबा फर्स्ट तर एरिया कोन कोन कर्व अछि then area then point then we discuss so this is a sample mo layman concept कहली so next class we will discuss the phase diagram of water system आपको बेस करियम पड़े तो हमें एडी मन रखले गोटे वन कंपोनेंट फेज डायग्राम रे कोन so so हमें गोटे डायग्राम कलर लिखिबा व्हाट इज दी तार डायग्राम ड्रा करिबा तार फेज लिखिबा एरिया कर्व डिग्री ऑफ फ्रीडम then why this curve in inclined to pressure axis so detail लिखियो पड़ियो so mo next class रे will discuss the phase diagram of water system I will send the recording of this class okay you can leave now
attendance
कोला
attendance
तो अटेंडेंस में क्लास करछु ना पाठ पढ़े में क्लास करछु I know the more automatic system of recording कर कि attendance class I have record all the things so I can know the who is present here okay so don't cheat with me होला तुम जानची को पिला ठीक से क्लास को करनी I can know that okay तो धरा पड़े तो सब पूरा जे धरा पड़े खाली बंक रे थिबो मो क्लास खाली माने ऑन कर दे पळै थिबो and make all the classes absent I have a mechanism that where that all the attendance recorded okay so that's why I not need to any attendance here ହେଲା So all of you now leave the meeting.